Okay. I chose problem number 2. Robin Hood fires an arrow 45 degrees up above the horizontal. The arrow strikes the target, a tree that is 220 meters away. The launch, the impact is at the same height as the launch. And the question is, how long is the arrow in the air? To find that, I get all the information together. I start with the x initial position, which is 0, y, which is 0. Final x is 220. Final y is 0 because it just goes up and back down to 0. Yeah. The velocity x original start is the I use the vector graph thingy or the motion graph. So this is a VO cosine of 45. I don't know what that number is. It just wasn't given. And it's cosine because it's the adjacent over hypotenuse, and the sign here for y because it's opposite over hypotenuse of 45. So it's VO sine of 45. Now solve it. I use these two equations, and I just plug it in. 220 minus the start is 0, plus VO cosine of 45t, plus 1/2 a, which is 0, so I can cross that out and cross that out. And now I go over here and I do it for y. The ending 0, start 0. This is 0 is 0, plus VO sine of 45t, plus 1/2 negative 9.8 for the acceleration, t squared. Over here I find the velocity in relation to time. And I do that by dividing the cosine 45t, 220 divided by that. And I put that in for the VO over here in the y. So I get 220 divided by cosine of 45 times sine, or like with the t there, times sine 45 with the t, plus 4.9 t squared. And now I can write it better by saying 220 sine of 45 t over cosine 45 t plus 4.9 t squared. Now cosine of 45 is the same thing as sine is 45, so I can get those out and t also. And now I have left at 220 plus 4.9 t squared equals 0. Oh wait, no, that's supposed to be minus because of the negative acceleration of gravity. So plus 4.9 and now 4.9, I got t squared, 220 divided by 4.9, and that t squared equals 44.898. Then I square root t, the time, is 6.7 seconds from here to there. There to there. Now, the second part of the question is, if someone was waiting on the tree, like up on the tree, and to drop an apple, how long should they wait before they drop it after the launch of the arrow? Now, to do this, I have to find the drop time from the start, like from the start of the drop to the impact, and then I subtract the previous answer by that at this time, or this time. So I use the same equation, but for one-dimensional analysis. So 6 equals 0. The starting is 0 plus 0 for the velocity start plus time, which is 0. Like, well, it's not 0, but it goes to be 0. And 1/2 acceleration, 9.8. This case, gravity is positive because it's, if you're looking in the negative direction, like going down, t squared. So 6 divided by 4.9, which is that. And that is 1.224. That equals t squared. I square root both, and then I get 1.1. Time equals 1.1 from the apple to fall from there to there. And now I get this answer that I had up here, which is 6.7 minus 1.1, and that equals 5.6. So he should wait 5.6 seconds before the apple is dropped from up here to go down there. That's the answer. Thank you.